And we're back with another video. Hey guys, it is your teacher here. I want to start this off with a water starter pack. Classic, original meme. What more can you ask for? Very funny if you understand it. Alright, let's get moving. This is going to be a short video today because we're just talking about one thing, and it is this. You really need to understand this picture if you want to do well in this external. So, what's happening here? These are hydrochloric acid molecules. Each of these is an individual molecule, okay? So you have your hydrogen here and it's bonded to your chlorine. We're going to learn what bonds are later on, but for now just think of them as a connection, like they're tied together. Here, the chlorine has a slight negative charge and the hydrogen has a slight positive charge. The reason for that is, we're going to come to it again in a second, it's because the chlorine is what we call electronegative. Let's just think of these as slightly negative and slightly positive charge. What we've got here is a connection between the hydrogen of one molecule and the chlorine of another. This is called an intermolecular attraction. Intermolecular attractions, or intermolecular forces, are forces between two molecules. Like, think international travel, which is now banned, but international travel is similar to intermolecular forces. Instead of going between countries, you're going between molecules. These are the forces that are broken when something is heated up and turned into a gas. So, hydrochloric acid, it's a liquid at room temperature. If we heat it up, you're breaking these connections to turn it into a gas. You're not breaking these bonds here, okay? These bonds are super strong and will not get broken. These bonds are weaker and will get broken with heat. The bonds between the hydrogen and chlorine, they're called intramolecular attractions. Intramolecular, not intermolecular. We can just call these bonds. This specifically is a covalent bond. We're going to get to covalent bonds after the holidays, okay? So intermolecular attractions, this is what's broken with heat. These are not broken with heat, okay? So when we're looking at how strong a solid is, we're looking at how strong these forces are. Okay. This is another way of thinking about it. You've got your hydrogen, your chlorines, your hydrogen, your chlorines, and the bonds between them are like needle and thread, so we've sewed them together. Okay? And that's really strong. Then between the molecules, we've just got some Velcro. So the Velcro goes in between here. And when we heat up the molecule, it's like we're pulling on this here. When we pull on the molecule, what's going to break first is the Velcro and not the tightly sewn needle and thread. Cool. So these are the notes you need to write down for today. Intermolecular forces. These are forces between individual molecules. In ionic solids, the intermolecular force is the electrostatic forces between positive and negative ions. So this is like your magnet forces, okay? When we heat it up, we're breaking these electrostatic forces and we're turning it into a liquid. Metallic solids. These are metals and they're held together by delocalized sea of electrons, and they hold the metal cations together. Intramolecular forces. These are bonds between atoms within the same molecule. Alright, that is all for today. There'll be a task going along with this video and you can find it on the Google Classroom. Thank you.